All right, so here we go. Quiz 10 study guide. And problem number 1, AB is tangent to circle O. So that means we have a 90-degree angle. A to O is 40. B to C is 45. What is A to B? So we need this leg of the right triangle. So if BC is 45, then C to O is 40 because it's a radius. So we're going to set up the Pythagorean theorem. AB squared plus 40 squared equals 85 squared. So subtract 40 squared from each side. AB squared equals 5625. And then find the square root of each side. So AB equals 75. All right, problem number 2, you're told that BC is tangent to circle A at B and circle D at C. That means these are both 90 degrees. Not drawn to scale. A to B is 10. B to C is 24. D to C is 6. Find AD to the nearest tenth. So we need A to D, which isn't drawn in here. So I'm going to draw it in here. Now, what we've got to do here is build a triangle with AD as the hypotenuse. And the way we're going to do that is we're going to take BC, and what you have to imagine is taking this segment BC and sliding it this direction until its endpoints are on D and this segment over here on the left. So let me move this real quick. So if I go up 6 units to here and I go from B towards A 6 units, I'm just moving BC and I'm moving it to here. And now since I slid it on a parallel, it still forms a right triangle. And if AB was 10 to begin with, and I moved it 6 units to keep it parallel, well, that makes this piece 4. All right, here's our 6, here's our 4. If BC was 24 to begin with, it's still 24. And we need AD. So it's just a matter of sliding BC the same distance on both ends and forming a new right triangle. So now we get 4 squared plus 24 squared equals AD squared. So 592 equals AD squared. Let's find the square root of both sides. So 24.3 is equal to AD. Similar problem here, a chain fits tightly around 2 gears. The distance between the centers of the gears is 31. So here's the center of the gears. This piece is 31. The radius of the larger circle is 19. So this distance is 19. Find the radius of the smaller gear around your answer to the nearest tenth if necessary. All right, so what we're going to do is we're going to take this 29-inch piece and we're going to slide it this direction, parallel, until we get it here, creating a new right triangle. All right, if this was 29 units to begin with, it's still 29 units. What we're going to find now is this short leg. If we find this short leg, subtract it from 19, it'll tell us how far we moved this segment, which is the radius of the smaller circle. So we go x squared plus 29 squared equals 31 squared. Subtract 29 squared from each side. $120, and then we square root both sides, so our x equals 11. Now, that's what our x is equal. That's what this piece is equal to, okay? If that piece is equal to 11, then the radius of this smaller circle, the radius is equal to 19 minus 11. And 19 minus 11 is 8. So radius of the smaller gear, that's 8. Put a star here, something to remind yourself that once you solve for x, you got to subtract it from the radius of the bigger gear. All right? AB is tangent to circle O at B, problem number 4. If AB is tangent, then we have a 90-degree angle. Find the length of the radius R for AB equals 8. A to O is 11.2, so this whole hypotenuse is 11.2. So R squared plus 8 squared equals 11.2 squared. Subtract 8 squared from each side. I get 61.4 equal to R squared, and then we will square root both sides, and I get 7.8. All right, problem number 5. When you do this problem tomorrow, I'm going to suggest that you draw it big on a piece of scrap paper, and you're going to see what I mean here in a second. This isn't a difficult problem, but it's a problem that you have to stay organized when you're doing. All right, the first thing I like to do is get all these dimensions on the problem. So R to S is 7. S to T is also 7. T to U is 6. And U to V is 5. And V to R. V to R is 8. All right. So pentagon is circumscribed about a circle. Solve for x for these dimensions. Figures not drawn to scale. We have to solve for this x right here. First thing we want to do is find the perimeter. All right, perimeter of this shape is the sum of the sides. So 7 plus 7 is 14, plus 6, plus 5, plus 8 is 33. Now, the second thing that we have to do is write all these tangent pieces in terms of x. So if this first tangent is x units, then this tangent is x units. All right? Two tangents from the same external point are congruent. Now, if r to this point of tangency is x units and the whole side is 7, then this piece is 7 minus x. If that piece is 7 minus x, it's congruent to this piece. Two tangents are congruent. So right here is also 7 minus x. Here's where you got to be careful. If s to t is 7, and this tangent is 7 minus x, then this tangent is 7 minus x. Which makes this tangent 7 minus x. Now, at this point, you want to simplify this. 7 minus a binomial means that you have to distribute this minus sign. There's really a negative 1 in front of the parentheses. So when we distribute this, we get 7 minus 7 plus x. 7 minus 7 is 0, and we're left with a positive x. So this piece, this tangent, is x units long. And if that piece is x units long, then the piece it's congruent to is x units long. And what I would do when you get here, when you've simplified these two congruent tangents, I would put a line through this. Because what we're going to end up doing is adding all of these congruent pieces or tangent pieces together. So again, if this tangent is x units long, then this tangent is 6 minus x units long. And this tangent is also 6 minus x units long. It makes this top tangent from V to this point of tangency now 5 minus 6 minus x. Again, you got to distribute this negative sign. When you distribute the negative sign, you get 5 minus 6 plus x. And 5 minus 6 plus x is negative 1 plus x. So that piece is negative 1 plus x. And I would scratch these out because you're done using them. If that tangent is negative 1 plus x, then this tangent is negative 1 plus x. Now, everything that isn't scratched out has to get added together and set equal to 33, because that would represent the perimeter of the pentagon in terms of x. So if you have a colored pencil or highlighter or something like this, you're going to want to use it tomorrow. Because look, I'm going to start at R and I'm going clockwise around this pentagon. So I'm going to take x minus x. Well, x minus x is 0, so those two x's cancel out. And then I've got a negative x and another x, and those two cancel out. Then I've got an x and a minus x, and those two cancel out. And then a negative x and a positive x. Those two cancel each other out. And then finally we have an x plus an x, which is 2x. So those are all the x's combined. Now we're going to go around again. We're going to do the same thing with the whole numbers. So I've got a 7 here, plus a 7 is 14. Plus this 6. 14 plus 6 is 20. 14 plus 6 is 20. Plus this 6. Which is 26. Minus 1. 24. 25, I'm sorry. Minus 1 is 24. So we get 2x plus 24, and it is equal to 33. So then we can subtract 24 from each side. And 2x is equal to 33 minus 24 is 9. And then divide both sides by 2. And our x equals 4.5. The key is to stay organized, working around the pentagon. And the other key is that when you have a whole number minus a binomial, you got to distribute. All right? A whole number minus a binomial, you have to distribute. And then just try to stay as organized as you can as you are combining your like terms. All right, problem number 6. J to K, K to L, and LJ are all tangent, not drawn to scale. J to A, JA is 7. A to L is 8. C to K is 12. Find the perimeter of JKL. All right, so look, if J to A is 7, J to B is 7. If K to C is 12, K to B is 12. If LA is 8, then LC is 8. So we've got a side that's 15. A side that is 12 plus 7, which is 19. And the side that's 8 plus 12, which is 20. So our perimeter is equal to 15 plus 19 plus 20. Which is 54. All right, problem number 7. Find the diameter of the circle for BC. 18. DC is 23. Round to the nearest tenth. Okay. So we're going to draw a segment in here from D to O. We're going to make it a tangent, so it's 90 degrees. Going to call it X. And if D to O is X units long, then O to B is X units long. And we're going to use the Pythagorean theorem to find X and then we're going to multiply it by 2, and that'll give us the diameter. All right, so x squared plus 23 squared equals x plus 18 squared. So we're going to multiply this x plus 18 squared. All right, x plus 18 squared is x squared plus 36x plus 324. And on the left-hand side, we still have x squared plus 23 squared. So now we have an x squared on each side of the equal sign, so we can cancel those out. And then in our next step, I'm going to subtract 324 from each side. So in the calculator, 23x squared minus 324, 205, equal to 36x, divide by 36, and 5.7 is equal to x. Now again, be careful, because they're not asking you for x, they're asking you for the diameter. The diameter is all the way across the circle. So the diameter is equal to 2 times the radius, which is 5.7. 11.4 is the diameter. Problem number 8, determine whether a tangent line is shown for AB is 8, OB is 3, AO is 8.5. Well, if AB is tangent to circle O, then what we're asking here is, does 3 squared plus 8 squared equal 8.5 squared? If it does, then that's a tangent. If it doesn't, then it's not. So 3x squared plus 8x squared, we get 73. Is 73 equal to 8.5 x squared equals 72.3? They're not equal. So determine whether a tangent line is shown. It is not. Or no, 73 does not. 3 squared plus 8 squared does not equal 8.5 squared. It's not a right triangle, so this angle is not 90 degrees. If that angle is not 90 degrees, then AB is not a tangent. And then we're going to do the same thing for number 9. Determine whether a tangent is shown. Now AB is 1.2. OB is 0.9. And the entire hypotenuse is 1.5. So does 1.2 squared plus 0.9 squared equal 1.5 squared? 1.2 x squared plus 0.9 x squared. I get a 2.3. Then 1.5 x squared, I get a 2.3. So if a squared plus b squared equals c squared, then yes, we have a tangent. If you had to explain, it would be, here's your explanation. Yes, 1.2 squared plus 0.9 squared equals 1.5 squared. Right? This is a tangent. That angle's 90 degrees. All right, problem number 10. Triangle NML. NL, the whole left side. All of this is congruent to NM. These two pieces are congruent. The perimeter is 50. A, B, and C are points of tangency. MC equals 7. Find NL, explain your reasoning. We're not going to worry as much about explaining the reason as we are about NL. Here's NL, this left side. So if these two big sides are congruent to each other, then we've got an isosceles triangle. Okay? And if we've got an isosceles triangle, we know that from the tangent rule that if MC is 7, then MB is 7. Now, if we were to put an X where N to C is, if these two sides are congruent to each other, then N to A has to be equal to X, and A to L has to be equal to 7. That makes both sides equal to X plus 7. And if LA is 7, then L to B is 7. So what we're going to do is we're going to take all of these tangents, add them together, set them equal to 50, solve for X, and then add that to 7. So we've got 2 X's plus we've got 4 7s. 4 7s is 28 equal to 50. So subtract 28 from each side. And our 2x equals 22. Divide both sides by 2. And our x is equal to 11. But that wasn't the question. The question was to find NL. All right, well, NL is equal to 7 plus x. So NL is equal to 11 plus 7, which is 18. All right, so nothing overly difficult. It's just I see a couple of problems where you have to solve for x and then insert it to get an answer or to get the answer to the question. And then there was that other problem where the toughest thing was staying organized. So be careful of those when you take your quiz tomorrow. That completes your quiz or your study guide for quiz 10. You've got the rest of the period to work on your electronic assignments or work on the study guide in the video.